Hello, and welcome to Game Revolutions, the series where I code up a bunch of bugs and then complain about them. In the last episode, I added the ability for the car to shoot. But what good is target practice without a target? Today, I add something to shoot at. Now, what is it that I want to add? What do I want to add? I want a rock. Da, 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 da. I want a rock. Da, 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 da. I want a rock.
Rock.
Bow, 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 bow. I want a rock.
Rock.
Bow, bow. I want a rock.
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 Rock. I want a rock.
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 Rock. You're looking at my highly advanced sprite editor, also known as the Visual Studio Code text editor. I just wrote some headers up here and some headers down here so that I know where each of these pixels would end up being. And this is my rock. It looks kind of weird and long, but keep in mind that the pixels are very far from square. They're much more long horizontally than they are vertically. So on the screen, this is going to appear much more scrunched up. Here's the same basic code you've seen before that draws the screen that I used to create the bytes to put into the assembly code. And I've added to this code to draw the rock based on that text file that you saw before. So I just kind of translated the coordinates into this data statement. And I use this to draw the main portions of the rock, and then there are some yellow streaks on the rock that I'm drawing here. And then the usual poking code that takes the portion of the screen that contains the rock, pokes it up into the very beginning of the screen buffer so that it has something that it can save M from. So on the disk, you'll see I do not yet have the rock binary, but I got my poke rock. Draws the rock, and then up here you'll see it pokes those bits up into the top, and now it's saving the file. And when it's all done, it just sort of hangs out here. So I'll break out, I'll do my dir, and there's my rock. And next I copy the rock binary from the Coco disk to my local hard drive. So now I have a rock.bin up here. Next, I have my little Java helper that converts a binary file to FCB statements. I use this for all sorts of things. So right now I have it configured to read from the rock binary. This helps it to know what portions to read and how to format the output. So let's run this. And here we go. So I take all of this and I paste it into my assembly. And here it is. And as you may recall, this is organized in such a way that it starts at the bottom and then it slowly goes up to the top. But within each row, these bytes are in order from left to right. That way, if I want to stack blast it, it's ready, but I don't think I'm going to be stack blasting the rock. As I was thinking about what I need the rocks to do, I realized that they behave just like holes. They scroll with the gravel from right to left. I could even make the rocks just about the same size, which is handy for jumping, so that when you jump, if the timing for the jumping is good for a hole, it should be good for a rock. So I decided that all this code for drawing holes, including looping through these hole offsets, and then for each one, calling this draw hole, which has all these crazy edge cases depending on whether it's just scrolling in from the right or just scrolling out on the left. And then all of this code to do the do. I'm like, this, I could just reuse all of this. The only difference is that rocks go above ground and holes go below ground. So now I have the concept of an obstacle. There's no longer holes and rocks, they're all obstacles. And whereas before I would have an array of offsets for each of the holes that are on screen, now I have an array of obstacle info structures. And this is global data, so this goes above and beyond what's on a given buffer at a given time. This is telling you the current state of the world. The obstacle info structure is pretty tiny. It just has a type, which tells you whether the obstacle is a hole or a rock, and then the offset that we had before that tells you where on the screen, horizontally, the obstacle exists. And inside the buffer info, which has the information for one of the two buffers for each of the buffers, rather than keeping track of offsets of the holes, we have obstacles drawn. And that is the obstacle draw info structure, which just keeps track of whether it is a hole or a rock, the offset where it was last drawn in this buffer, and what byte I should use to erase it. So depending on whether it's a rock or a hole, I might erase it with either red or green. And finally, onto the level progress array that tells you what should happen when. I have a new value here for rock that says a rock is supposed to come on screen. So these are the counters that tell you when, and then right after them is the thing that tells you what. Those two values are defined here. And then this jump table tells you, given what the value is, what routine should we go to. So we already had this new hole routine, which I just factored into the new obstacle routine. So that new hole and new rock basically call the same code, only difference being the type. And new obstacle simply finds the first unused obstacle in that array, that global array, and then fills out the fields with the initialized values for a new obstacle, which is really just the type, and then the 31 offset, which says it starts off at the right-hand side of the screen. My first draft of this code has a lot of duplicated code between the holes and the rocks. I plan to clean it up, but for now I just want to see what I can get working, so I'm not going to show you the code because it is too embarrassing. Hole. Rock! Oh! Now, of course, we're not supposed to go straight through the rock. That's something. All right, so like, can I jump over rocks? Jump over rocks? Okay, very good. Okay, I have made the code a bit more pretty. I've collapsed common parts of the code together. Okay. I should have expected nothing less. It looks like all of the erasing code has gone completely insane. That's what it looks like. Everything is getting erased with the wrong bytes. All right, I think I found the issue here. When I was collapsing code, started using different registers for things. This is probably a copy-paste error, or maybe I just forgot to change this, but it is the X register that we're adjusting to determine where the thing is going to be drawn. And I think this 13 offset is wrong. I think we want to go 14 lines down. So let's try this. Okay. Ooh, that looked good. Ooh, that looked good. Ooh. Ooh. It's incredible how such small changes make such large problems. Okay. Okay. That's good. All right, all is actually not so good. Keep your eyes on this part of the screen. I realized this later after running this for a while. If you run it for a long time, something starts happening over here. It does take a while. Odd that it would take a while, but it does happen. There it is. There it is. This, what the heck, man? It was blinky, and now it's not blinky, but this extra line up here does not belong here. Ugh. I have to narrow this down. I don't know why it would take so long. All right, I think I figured out the cause. Let's see if you can figure out the cause. What is different? What happens differently when that weird artifact shows up. It's not there, everything is fine. There is something different. There it is. Did you detect what happens differently? This isn't a timing thing, I don't think. It's a situational thing. Some kind of situation occurred that caused that to happen. If you missed it, here's what it is. As we go through the progress of the level, we're alternating hole, rock, until we do 2 holes in a row. So it took this long to get 2 holes in a row, and that's when that bug reared its ugly head. So if I want to reproduce this easier, I can just make the first 2 things holes. Now it should happen very quickly. We're fine. Second hole. There we go. Okay, good. All right. Now I can start debugging. Oh, interesting. It went away as soon as the rock got there. Okay. Okay, it's time to play Can You Spot That Bug? I think I have spotted it. Let's see if you can spot it. When it comes time to erase an obstacle, I'm loading my D register, with the bytes I'm going to use to erase it. So if it's a rock, I go up here, and I will erase it with green bytes. If it is a hole, I just fall down here, and I erase it with solid red bytes. And then down here, when it comes time to erase it, I'm just taking cases based on the offset so that I know, am I only erasing 1 byte? Am I only erasing 1 byte on the left or the right? Blah, blah, blah. And you should have already seen it. You should already have seen the bug. D, A, D, A. When I load D with the bytes, it trashes my A. Goodbye, A. As an aside, you probably realize I am not actually using this original byte inside the obstacle draw info. I was planning to use this to know what to erase it with, but it turns out that it's easier not to deal with this, and instead to just hard code to either red or green, because that branch of code also needs to adjust the pointers so that it knows where the rock or where the hole lives. So actually I can do away with this. Okay, so the fix was to change the register to something that I am not needing to use, and that will clearly fix everything. All right, let's check it out. I put like a 3rd hole in there to make sure. Yes, 3rd hole, very good. We get some rocks coming in. All right, another hole. Okay, good. So I think we're good. Well, it turns out when you are able to reuse a bunch of code, things go a bit more smoothly. Not to say that they go smooth, but compared to other stuff, they go pretty smoothly. So we now have things to shoot at. So maybe it's time to add hit detection. Until then, thank you for watching.